Greatest common denominator. That is when you find out what is the biggest number that can divide two numbers evenly, or without giving you a decimal. So for example, 10 and 6. 10 is built up of 2 and 5, 6 is built up of 2 and 3. So the biggest number that can go into both of them is 2. You should know that from prime factorization and that old algorithm. So you can even see, if I flip these over, I split them up into sections of 2. 10 is built up of 5 sections of 2. 6 is built up of 3 sections of 2. I can't split these into bigger sections where they both get... I can't split this into sections of, I don't know, 4. Well, first of all, 4 doesn't even go into both of them. I can't split them into sections. You get it, okay? But we're not doing that algorithm. We are learning a new way to do the greatest common denominator with the Euclidean algorithm. So if we did this the old way, we could split these down, do the prime factorization tree of each of them, cross out what matches, write those out, and get 18. But that's old and boring. We want something new and exciting. Well, actually, no we don't. But it's a cool way of doing things. Okay, so the first step of this is to take our two numbers, and I'm going to flip them over because we are going to be chopping and cutting, and I'm going to divide these two numbers. How many times does this number go into that number? Well, let's see. If I line these up and draw a line right here, and then go over here. Oh, nope, it's over. This only goes into that number once. So then I'm going to divide that number and get the remainder. Now the interesting part is that this number and this number, I think, let's see, 198 minus 108 is 90. Oh yeah, duh, I could have done that in my head. Okay, so that gives me 90. So the interesting thing is that because we're trying to find the number that splits these into even sections, we can almost already assume that x splits these up into even sections. So then we can see that even if we subtract these parts, the greatest common denominator of these two numbers is the same greatest common denominator of these two numbers, if that makes any sense. And that's basically how this algorithm works. So then we just take this number and throw it out the window. We don't care about it anymore. Because these two numbers give us the same result, we just take these two numbers and do the exact same thing. So we take our 90, divide it into 108, that goes into a 1 time, and then we get this small block as a remainder. And our calculator tells us that that number is 18. So cool. And then of course, the way the algorithm stops, because we just keep on doing this, we throw out this number again, and then we divide 90 by 18, and then we see that 18 goes into 90, 1, 2, 3, 4, 5 times. And our calculator can verify that. 90 divided by 18 equals 5. So, and then we say, okay, so that gives us a remainder of 0, and when we have a remainder of 0, we can stop. So, it's an interesting way of chopping and cutting and remaindering, and I can show you what that looks like on paper. And everything's flying everywhere. Okay, so we have 198 and 108. So then we take our division, we take 198 is equal to 108 times 1 plus 90, and this was our remainder over here. So then we just say, okay, now let's take these two numbers and plug them back in. So 108 is equal to 90 times 1, it only went in there one time, plus 18. 18, then we take these two numbers and do the exact same thing. 90 is equal to 18 times 5 plus 0. And then we take those two numbers and plug them back in. 18 is equal to, well, actually, there's a couple of steps of logic like in between each of these steps that checks, are either of our inputs 0? If they are, then choose the other number, because that's what the greatest common denominator is. And that is the Euclidean greatest common denominator algorithm. Thanks for watching.